All right, review for Unit 6 test on statistics. For each scatter plot, circle whether the relationship between the data is positive or negative. So positive relationship is when the data is going up from left to right. Negative is when the data is going down from left to right. So positive would look like this. Negative like this. This is a positive relationship. The data is going up from left to right. Here the data is going down from left to right, so negative. For each scatter plot below, circle whether the relationship shown is linear or nonlinear, then draw either a line or curve of best fit. So here, if we're trying to draw a line of best fit, it's going to end up being a curve of best fit, making it nonlinear. This one also has a curve of best fit, which goes, remember, it goes right through the middle of the data point, so about the same as on the top and bottom of your curve or line. And this one looks like we can draw a straight line of best fit right through about the middle of our points, making it linear. Circle an outlier in the scatter plot below. Okay, so our outlier is our data point right here. Explain why this point is an outlier. This data point is, let's see, I would say it's does not follow the trend of the rest of the data points. Circle if each relationship shown is strong or weak. So strong is when all those data points are really close together, and weak is when they are more spread out from that line of best fit. A scatter plot is shown below. Is there any relationship between this data? Explain your reasoning. So you can't draw a line of best fit. You can't tell if the trend is going upward or downward. So this is no relationship. There is no relationship between the data because, let's see, we cannot identify a trend. It is a bunch of scattered points. With no trend. Upward or downward. Data is randomly collected from students regarding the number of hours of sleep they got before a big test and then their scores. The line of best fit has this equation. Okay, what is the y-intercept? Interpret the y-intercept. So our y-intercept would be right here. The point 0.064 is our y-intercept. So what that means is the point right here. So they're saying if we were to draw a line of best fit, our y-intercept would be right here at 64. So what that means is when you have 0 hours of sleep, this is our x and this is our y, hours of sleep, and your y is your score. So when you get 0 hours of sleep, you'll get a score predicted of a 64. Circle the correct interpretation of the slope. Okay, so our slope is over here. 3.2, it's positive, so that means as our score increases by 3.2 points per hour of sleep you get, our score is increasing approximately 3 points for every hour of sleep you get. Increases because the slope is positive. A company collected data on the value of used cars in relation to the number of years since they were purchased. The company determined the equation y equals negative 750x plus 11,000. Models the used car value where x is the number of years and y is the car value in dollars. Based on the equation, what is the prediction of the value of the car after 8 years? So we said our years was x. X is the number of years. So we're going to take that 8 and plug it in for x. So y equals negative 750x plus 11,000. Let's plug in 8 for x and see what we get for 11 and see what we get for the y, which is the value of the car. Negative 750 times 8 plus 11,000. 5,000. The value of the car is $5,000 after 8 years. The predicted value of the car. All right. The scatter plot below shows a line of best fit for data collected on the value of used cars in relation to the number of years since they were purchased. Based on the line of best fit, what would you expect the value of the car to be 8 years after purchase? This is the same question, but just using the scatter plot. So if we go to 8 years, our line of best fit predicts $5,000. Okay, so same thing we got using the equation. Okay, a two-way table about hurricanes. How many Atlantic hurricanes were there? So we're going to look for Atlantic. Here's Atlantic. We have 57 in this category, 47 in this category. We have 104 total Atlantic hurricanes. How many Pacific hurricanes were there? Here are all of our Pacific hurricanes. The lower category, the higher category, totaling 114 Pacific hurricanes. How many Atlantic hurricanes were category 1 or 2? Atlantic and category 1 or 2 would be 57. Pacific that were 3 and plus. Pacific and 3 plus would be 50. Okay. The data in the two-way table shows the number of students at Croft Community School who ate a school lunch daily on average for this 2013-2014 school year. How many K-2 students were in the survey in total? Okay, so here's our K-2 students. We have 222 packed to school brought school lunch, 144 packed to school lunch. To figure out our total number of K-2 students, we can add those two up and get 366 total K-2 students. And then how many 3 to 5 students ate a school lunch? So let's go to our 3 to 5 students. We're going to want this information right here, 3 to 5 who ate a school lunch. So to figure that out, we know 222 plus whatever this is will add up to our 435 students who ate a school lunch. Or you could look at it as this number plus 122 will equal your 335 total K-5 students. So let's do both. We can take our 435 and minus 222, where we'll get 213. Or, so I was using these. Or we can use these. And take our 335 total number of 3 to 5 students minus the 122 that have a packed lunch. And we should get the same thing, 213. So either way, it is 213. Okay, let me just box my final answers in. And students in grades 7 and 8 were randomly surveyed to determine if they'd prefer to go to a science or math museum. What percent of the students of the students means all the students, we're going to use that grand total, are 8th graders who would prefer the Math Museum. So we're going to look for 8th grade Math Museum right here. 30 8th graders prefer the Math Museum of the students. So of all the students, this is the relative frequency. %. What percent of the students, again, 200 total students, would prefer the Science Museum? Well, we have 42 who preferred the Science Museum in 7th grade, 90 in 8th grade. 132 are preferring the Science Museum out of all of the students. %. What percent of the 8th graders prefer the Math Museum? All right. Of the 8th graders prefer the Math Museum. So we're going to look at all of the 8th graders, which I'm circling in purple right now. All of the 8th graders, there's 120 8th graders. Out of all those 8th graders, we want to know what percent preferred the Math Museum. 30 of the 8th graders preferred the Math Museum out of all 120 8th graders. 30 out of 120. 30 out of 120 times 100 to make it a percent, 25%. And lastly, what percent of the students who prefer the Math Museum, of the students who prefer the Math Museum, are in 7th grade? So we're going to look at all the students who prefer the Math Museum. And we want to say that there's 68 students who preferred the Math Museum in total. How many of them were in 7th grade? 38 of them were in 7th grade out of the 68 total of the students who were preferring the Math Museum. Convert that to a percent. We get 55.882, 35, and so on. The 8 tells the 5 to go up 1 to 56%. All right, there you go.